Okay, welcome back. And today we're going to cover section 7 of chapter 1. And so today we're going to now turn our attention to inequalities. And so we're going to talk about linear inequalities, three-part inequalities, and talk about what that is and how do we, handle those. And then quadratic inequalities, and then rational inequalities. So here are some properties of inequalities. And here it says let A, B, and C represent real numbers. 1, if A is less than B and you add a constant to both sides of the inequality, then the inequality is still the same. It holds. Okay. So if A is less than B, then A plus some constant is still going to be less than B plus the same constant. 2, if A is less than B and if C is greater than 0, then multiplying both sides by C will not change the inequality. Okay, so A times C will still be less than B times C. If A is less than B and C is negative, so C is less than 0, then the sign will flip. So A times C will be greater than B times C. So this third one is the one you got to watch out for, because whenever you multiply or divide by a negative number, you must flip the inequality. Okay. And also, you can replace with any one of these symbols and you're going to get similar results for the properties. Now, multiplication may be replaced with division in properties 2 and 3, but remember to reverse the direction of the inequality symbol when multiplying or dividing by a negative number, which I just said. Now, linear inequalities in one variable. So just like we talked about linear equalities, right? Linear equations. We can also talk about linear inequalities in one variable. Okay, and so we're going to solve for the inequality, right? We're going to solve for x the same way. Okay, and again, where a and b are real numbers with a not equal to 0, of course, right? And for the same reason that we talked about before. Now, let's solve this, right? So all we're going to do is we're going to solve for x, just like we would for an equation, right? So we want to isolate the x variable on one side of the inequality and then put everything else on the other side. So the first thing we're going to do is what? Subtract 5 from both sides. Okay, and what does that give us? That gives us negative 3x is less than negative 12. Okay, and then what do we do now? We're going to divide by a negative 3, but remember, we're dividing by a negative number, so that means we're going to flip this to a less than sign. Okay, so this becomes what? X is less than 4. Now, a couple things you want to understand is the different types of ways of describing or denoting intervals, right? Because when we're talking about inequalities, we're always talking about, or most of the time we're talking about, a range of values, right? A set of values. So when we're talking about intervals, right? So here we're talking about an open interval. And there are different ways we could show this. We could use set notation, right? So we got the curly braces that represent sets. And then we have x, and then we have this vertical bar, and then after the vertical bar we have the rule. And so the way we would read this is this. We would say the set of all x such that, that's what the vertical bar means, such that what? What has to be true? That x is greater than a. So this is the rule that must be true. This is the rule that tells you what is going to be inside the set and what is not going to be inside the set. This is called interval notation. Okay, so we use the parentheses or brackets down here if we're including the endpoint. But we can write interval notation. So we got set notation, interval notation, and then we've got the graph. We can graph it. So if we say the set of all x such that x is greater than some number a, then that would be the same as the interval from a, right? Greater than a means that we want everything that's greater than a. So the curly brace means that we're, or the parenthesis means that we're not including a in the set. So that means everything greater than a, so from a to infinity. So this is another way of representing the range of values that's in a set. Okay, so we're going to say everything greater than a up to infinity. Okay, but not including infinity, of course. And then how do we graph that? Well, we can use the number line, right? We can use the number line, and we could graph it on the number line and put a parenthesis here at a showing that we're not including it, or sometimes you can also use an open circle, okay, and then a bold-faced line to the right or to the left if appropriate. And so this is the way we're going to use to denote solution sets when we're dealing with inequalities. Okay, so the type of interval. Here's a closed interval. Okay, so we got open intervals. We've got other intervals, right? So we've got where it's closed. So this bracket here means that you are including a in the interval. Okay, here you're not including a, but here you're including b. So everything between a and b, but not including a and including b. And then, of course, the other way around. And so these are different other intervals. And so here's a closed interval. So now here's the set of all x such that x is between two values, right? So that would be represented by this symbol. And then, of course, on the graph would look like this. Or we could say an or statement, right? So we want x such that x is either less than a or greater than b. So we use a union symbol. And so that means that we're going to have going outward. So we're going to have a little break here. So we want everything to the left of A and everything to the right of B. And then, of course, we have the interval of all real numbers, which can also be represented as a bold-faced R. And so we could write it this way. We want the set of all x such that x is a real number. And so in interval notation, just go from negative infinity to positive infinity. And so here it would be represented as just the whole number line by using arrows. Okay, so let's solve this one. So it says give the solution set in interval notation. Okay, so the first thing we're going to do is we're going to solve for x. So we're going to isolate x on one side of the inequality. So we're going to subtract 4 from both sides. And then we're also going to subtract we're going to subtract 2x from both sides. We combine like terms, right? So this 4 cancels with this 4. And so this gets combined with this, so we get 3. So this is what we end up with. And now what we're going to do is we're going to subtract 2x from both sides. And then combine like terms. And then now what we're going to do is we're going to divide by what? Negative 5. Now remember, we have to flip the sign. So we flipped it from less than or equal to greater than or equal to. So that means x is greater than or equal to what? Negative 3/5. And so how do we graph this? Well, it's greater than or equal to, so it includes the equal sign. So it's going to be a bracket, a square bracket. And so at negative 3/5 and greater than negative 3/5 is always to the right. So this is what we would highlight. So this is what you would expect to see. And that's the interval notation right here. So this is interval notation. So you would have to put a square bracket to note that we are including negative 3/5 in our solution. And then we'd have a parenthesis with an infinity, showing that it just like the graph, it's everything that's equal to negative 3/5 and greater than. Now, if the revenue and cost of a certain product are given by these examples, okay, so this is the revenue function, right? So this X is the number of widgets that you sold, and this is the price that you're selling them for. Okay, so this is 4 times X. And then the cost is the cost of making the widgets. So you have a fixed cost, and then you have a marginal cost, which is basically a cost per widget, right? So most of the time you're going to start out in debt, right? Now, here's what we're going to do. It says X is the number of units produced and sold. It says at what production level does R at least equal C? At least equal C. So what value of X is R what? Greater than or equal to C. Okay, so what is the minimum, right? What's the what is the let me see here. It says so what is the X value where R is equal to or greater than the cost? So now the set is what we want the set of all X such that R is greater than or equal to C. So we start with this and we substitute. And now what we want to do is we want to subtract 2x from both sides. And we're going to get 2x. And then we're going to divide by 2. We get x equals 500. So that is the minimum amount. Okay, so the minimum amount that the company needs to sell is going to be 500 units. So the break-even point is 500 units. Okay, so this product will at least break even if the number of units produced and sold is in the interval from 500 to infinity. So now let's solve this one. Okay, so now look at this is a double inequality. It's a 3-part inequality. Okay, so you've got 2 inequalities here. So what we're going to do is we're going to isolate the x in the middle, and whatever we do to the middle, we're going to have to do to all 3 pieces. So the first thing we're going to do is we're going to subtract off the 5. Okay, so I'm going to subtract 5 from here and subtract 5 from here. Okay, so we're going to subtract 5 from all 3 pieces. So this is where we get 0 here, so that's good. And so we get this. And so now we're going to get rid of the 3, right? So it's multiplication, so we're going to divide by 3. So we get 1. But then we have to divide all the other 2 pieces. by 3 as well. And so you get that x is between, right? So x is greater than negative 7/3 and less than 5. Okay, so this is the interval notation, right? So this is the solution set. The interval is going to be from negative 7/3 to 5. And notice that they're using two parentheses. So quadratic inequalities. Okay, so a quadratic inequality is an inequality that can be written in the form of ax squared plus bx plus c less than 0. Okay, and we could also replace this with any of the other three inequalities as well. Okay, and we're saying where a, b, and c are real numbers, with obviously a cannot be equal to 0. So now how do we solve for quadratic inequalities? Well, it's going to be the same, or not the same, but it's going to be this very similar to what we did with equations, solving equations, linear equations, or quadratic equations. So step one is we solve the corresponding quadratic equation, right? So we change it to an equation, we solve for the corresponding quadratic equation. And then we're going to identify the intervals determined by the solutions of the equation. And then we're going to use a test value from each interval to determine which intervals form the solution set. Okay, so let's solve this one. So we've got this quadratic inequality. So we've got this quadratic, so we're going to treat it like an equation. So step one, we're going to find the values of x that satisfy this. So we're going to find the roots, the zeros, right? So we're going to use the factoring, right? So what are we going to do? Corresponding to the quadratic equation, right? So we're going to factor it, and now we're going to use the zero product principle. And we find that x is equal to -3, or x is equal to 4. Okay, now this is what we're going to use to split up the number line into intervals, right? So that's where it's going to be 0. We want to find where is it equal to or negative, right? Below 0. So we just, now these are cutoffs, right? So what we know now is that it's either going to be negative on the left of -3 or the right of -3, or the right or the left of 4 to the right of 4. Okay, so we're going to use these to split up the number line into 3 intervals. Okay, and so this is where we're at. So these are the zeros. So it's got to be negative or positive here, negative or positive here, negative or positive here. So what are we going to do? We're going to use a test point. We're going to choose a point over here. We're going to choose a point over here, which zeros, obviously the obvious choice to use here, very easy to use. And then we're going to choose a test point over here, and then we're going to use those points to determine what is the value of the expression. Is it going to be negative or positive? Okay. So now we're going to choose our test values. So here we use -4, right? So you usually want to test a value close to the 0. Okay, so here we choose -4. So we stick in -4 in for our equation for the expression, the quadratic expression. What do we get? We get 8. Is 8 less than 0? False. Okay, so that's not going to be it. 0 is easy. So 0 gives us -12. Is -12 less than 0? True. Good. So that we got one interval. Now we still got to test the last one, 5. Does 5 give us a negative number? No, it doesn't, so it's false. So guess what? So here is the interval that satisfies the inequality. So our solution set is from -3 to 4. Okay? So now, what about this one? Okay? So what do we have here? Now we're going to do the exact same thing. Okay? Okay, so what we're going to do is we're going to find the values of x that satisfy the equation, right? And then we're going to factor and see if we can factor this. Okay. So here we get these two factors. Okay. Now, again, if you don't understand how to factor this, please go back and review the different factoring. So here we're going to use the AC method, right? So we're going to multiply 2 and 12. 2 and -12 rather, and find the all of the factors. And we're going to find and look for two factors of -24 that will add and give 5. Okay, and then we're going to use decomposition to solve it. So again, just make sure you know how to do that, because this is going to come back over and over again. So now we have our factors. So now this means what? We're going to use the zero product principle to say that, hey, either this is equal to 0 or this is equal to 0. And now we solve both of these or each of these separately or independently. And we end up with x is equal to 3/2 or x is equal to -4. Okay, and so now again, these are where the zeros are at. So this is where we're going to partition. This is what's going to help us partition the number line. Okay, so now we've got our three intervals that we're going to test. So here, obviously 0. Now here's the key. Why are we using a test point? Because if it's 0 here and 0 here, that means in here it has to be the same sign. Okay, so it has to be all negative or all positive. And same thing here, all negative or all positive, or all negative or all positive. Because if it went from negative to positive over here somewhere, well, that would mean that it would have to cross at 0. We would have another 0 over here. Well, so that's why we find the zeros. Okay, so now we're going to use a test point over here. So here, -5 would be an obvious choice. Here, obvious choice would be 0. And then over here, the obvious choice would be 2. Okay, use 2. Okay. And so we plug those values in. And what are we looking for? We're looking for if it gives us a value that is greater than or equal to 0. So over here, we're looking for positive. So yes, it is greater than or equal to 0. And then we put in 0 here for this interval, and we say no, it's not greater than or equal to 0, so that's false. Then we stick in 2 here and solve, and we get 6 is greater than or equal to 0, and that's again another true statement. So now we've got two intervals that satisfy the given quadratic inequality. So now the way we do our solution set is we're going to use a union, because the values of intervals A and C make the inequality true. So the solution set is the union of those two intervals, because we're going to take both of those intervals and put them together. Okay, and so we say the interval from -∞ to -4 unioned with, or union, 3/2 to +∞. Okay, and notice, oh, hold on a second. Hold on a second. So this is greater than or equal to 0. This should be a square bracket, because it is 0 at -4. So, and we say greater than or equal to. So this would be a square bracket. This should be a square bracket, not a parenthesis. Okay, just note that. Okay, inequalities that use the symbols less than or greater than are called strict inequalities. If you have the equal sign with it, like less than or equal to and greater than or equal to, these are called non-strict inequalities. The solutions of the equalities in example 5 were not included in the solution set since the inequality was a strict inequality. In the last example, example 6, the solutions of the equation were included in the solution set because of the non-strict inequalities. Okay, so in other words, if it includes the equal sign, then it's a non-strict inequality. If you don't have an equal sign, then it is a strict inequality. So now let's look at finding the projectile height. So if a projectile is launched from ground level with an initial velocity of 96 feet per second, its height s in feet t seconds after launching is given by the following equation. So in this here we have the height, okay, which is the position of the projectile, could be a rocket, an arrow, whatever, is given by this, negative 16 t squared plus 96t, where this is the initial velocity. Okay. So now it says, when will the projectile be greater than 80 feet above ground level? So first of all, we set this up as an inequality, right? So we want to set this up as greater than 80. And so now what we're going to do is we're going to bring the 80 over and set it up like we would like with standard form. So now we have this quadratic expression over here greater than 0. And so now we're going to go through those steps. Okay. Now why did we do this? Because we divided by negative 16. We wanted to get rid of that negative 16, right? So we divided everything by negative 16. And we get this one. Now it just happens that these are all divisible by negative 16, okay, by 16. And so we get this inequality. Now we can solve using the corresponding equation. Now we got a quadratic equation, which we know how to solve from the previous section. And so now we're going to factor this and look for the zeros. And the zero product principle tells us that, hey, t is equal to 1, or t is equal to 5. So what does this tell us? What does this tell us? This is telling us that the height of the projectile is equal to 80 feet when t is equal to 1 second, or t is equal to 5 seconds after the projectile is launched. Okay. Now, but we want to answer greater than. Okay. Well, right now I could tell you that at once, if it was equal to 80, right, and you're shooting it upward, if it was equal to 80 here and equal to 80 here, then it was above 80 feet between 1 and 5 seconds. But let's look closer. So let's go through the process and see if we're right. So let's go through our steps. So here we're going to do our test point here, which we'll use 0. Here we'll use 1, and here we'll use 6. Okay, so now let's do it. Okay, so again, if you choose 0, this is going to be false, this is going to be true, and this is going to be false. So if you use 0 here, if you use 1 here, and let's say use 6 here. Okay, and you'll find that the interval where the projectile is greater than 80 feet is from 1 second to 5 seconds. Now, solving a rational inequality. Here are the steps. Rewrite the inequality if necessary so that 0 is on one side and there is a single fraction on the other side. Okay, that's the first step, okay, if necessary. 2, determine the values that will cause either the numerator or the denominator of the rational expression to equal 0. These values determine the intervals of the number line that we're going to consider. And then step 3, use a test value from each interval to determine the intervals, which intervals form the solution set. So now a value causing the denominator to equal 0 will never be included in the solution set. If the inequality is strict, any value causing the numerator to equal 0 will be excluded. Okay, if the inequality is non-strict, any such value will be included. Okay, so we'll do some examples of that. So let's look at this one. So here's a caution though. It says solving a rational inequality such as this one by multiplying each side by x plus 4 to obtain the given inequality 5 is less than or equal to x plus 4 requires us considering two cases. Okay, so you got to be careful here. Since the sign of x plus 4 depends on the value of x, right? Because if we choose a certain value of x, we're going to end up getting a negative value, or we could end up getting a positive value, which is going to change things. Because if x plus 4 is negative, then we're going to have to switch the symbol because we just multiplied both sides by x plus 4. Well, we don't know if x plus 4 is negative or positive, right? It depends on what x is. Okay, so we're going to have to consider two cases. Okay, so the procedure used in the next two examples eliminates the need for considering separate cases. So make sure that you do this. This will simplify things. So let's look at this. Okay, so how would we solve this instead of having to deal with two cases? I mean, you could deal with two cases, but why deal with two cases if you don't have to? So here's what we're going to do. We're going to bring everything to one side. And so then we're going to change this into one big fraction. Okay, and so what we're going to do is we're just going to make this into what? X plus 4 over x plus 4, so we can have a common denominator, right? So now we can bring it together with a common denominator and bring the numerators together. So we can subtract the numerators and keep the denominator, right? And so now, remember, we're subtracting this entire thing, not the x, okay? So put the parentheses around there so it helps you not to make a mistake, okay? And this helps remind you that you have to distribute the negative sign to both of these. Now, if you do that, you get what? You get negative x, what? Plus 1. Right? Or 1 minus x over x plus 4 is greater than or equal to 0. Okay, now be careful with the sign. So now this is where things become straightforward. The quotient possibly changes sign only where x values make the numerator denominator 0. Okay, so we're going to find the zeros of this thing, right? So when is a fraction or rational expression 0? When the numerator is 0. So we want to find all the values where the numerator is 0, so we can look for the our intervals. So this occurs at x equals when 1 minus x is equal to 0, or when the denominator is equal to 0 at x plus 4, because we can't have any restricted values, right? So the bottom tells us what all the restricted values are when this is equal to 0. The numerator tells us where the whole function, when is the whole expression equal to 0. So x equals 1, and we get x equals negative 4. Now, negative 4 is going to be a restricted value. Okay, now, notice what they did here. Here, negative 4 is a restricted value, so they put a circle around it. It's an open circle saying that, hey, we are not including 4. It's basically we're using it to partition and to find the intervals that we're interested, but negative 4 is not included. But 1 is included. So now we're going to use our test points to test each one of these intervals. Okay, so we're going to use negative 5, 0, and 2. And so we find that when we plug it in, so we're looking for values that are greater than or equal to 1. Well, is negative 5 greater than or equal to negative 1? No. So that's what we get. We get 5 over negative 4 plus 5, which gives us negative 5. Negative 5 is definitely not greater than or equal to 1. Then we put in 0, so that gives us 5/4. And 5/4 is greater than or equal to 1. Okay? And then 5 over 2 plus 4, which is 6. So 5/6, is that greater than or equal to 1? And that is false. It is not. So now step 3, we find, after our tests, that the values in the interval from negative 4 to 1 satisfy the original inequality. The value 1 makes the non-strict inequality true, so it must be included in the solution set. Okay? So since negative 4 makes the denominator 0, it has to be excluded from the solution set. So the true answer is going to be the set of numbers from negative 4 to 1, with negative 4 not being included and 1 is included. Now be careful with the endpoints of the intervals when you're solving rational inequalities. Okay, be careful with the endpoints. So now let's look at this inequality. So let's do the same thing. We're going to move everything to one side of the inequality. Right, so we're going to subtract 5 from both sides. And then we're going to what? Here, we're going to multiply the top of the bottom over here of the 5 by this denominator, right? So we're going to multiply, we want a common denominator, so we're going to multiply the top and the bottom by this. And so that's what we get. And now we're going to simplify this, and we're going to simplify the numerator. And now that we have a common denominator, we're going to subtract across the top and keep the bottom. And so now, remember, we're going to distribute the negative 5 first, so we're going to use the distributive law. And so this is going to be negative 15x minus 20. Negative 15x minus 20. Okay. Now, be careful with the signs. Okay. This is positive 2x. This is a subtraction, right? So I have 2 x's, and I want to subtract 15 x's. How many x's am I going to have if I subtract 15 from 2? Well, I'm going to go negative, so it's going to be negative 13x. And now this is negative 1 minus 20. So it's a negative 1 minus 20, which gives me a negative 21. And so that's what we get. So now we're going to solve for the numerator and the denominator, find out where those are equal to 0. And remember, when this is equal to 0, that's telling us where all the zeros are. When the bottom is equal to 0, then that's telling us where the restricted values are, and we need to know those as well. Okay. set the numerator and denominator equal to 0, and solve for the resulting equations to find the values of x where they may change, or where the sign changes may occur. So here we go. So this is set equal to 0, this is set equal to 0, and so we get x equals negative 21 over 13, right? So negative 21/13, or x is equal to negative 4/3. Okay? So now this is what we're going to do. So now, here, negative 4/3, so look at, it's a strict inequality, so both of these are going to have open circles, okay? Because we're not including we're not including this one because it's a restricted value, but we're not including this one because it's a strict inequality. So now we're going to do our test points. So this is going to be like, let's say 0, and we're going to pick another number between these two. Okay, and so let's pick, let's see here, 1, no, not 1, 2 won't work. What can we use? Yeah, that's a tough one. What are we going to use? Okay, so I guess they're going to use negative 1.5. I guess it's, sometimes you have to use it. So now let's choose our test value. So we're going to use negative 2, negative 1.5, and then of course 0. Now, because we're using the less than, the strict inequalities, neither endpoint satisfies the inequality, so the solution set is going to be the union of these two sets. Okay, and again, if you don't understand why these are the two sets and why we're using a union, ask, okay, or go back to the other example that we did where we did use that. Okay, so that is the end of this section. So next time we're going to finish up chapter 1 with section 8. And remember, go through these on your own, practice these examples, practice the suggested homework, practice the other examples in the textbook, so there's a lot you can do. So just make sure you do that, and make sure you ask questions. So come to class prepared to ask questions, or you can email me those questions as well. But make sure you're watching these videos before you get to class. So until then, keep it up, and I'll see you later. Have a great day.